Hello, calculus students. This is section 5.2, the definite integral. We've worked with the indefinite integral where you integrate and you get that plus c. Related to that antiderivative, now we're kind of putting the two together. Here it says, here's a definition, let f be a function defined on the interval a to b divided into n subintervals of equal width, delta x equals b minus a over n, where a is equal to x sub 0, then comma x sub 1, x sub 2, all the way to x sub n is equal to b, are the end points of the subintervals, and x sub 1 star, x sub 2 star, all the way to x sub n star are values on the subintervals. Provided the limit exists, the definite integral of f from a to b is, and I put it on this side, the integral from a to b of f of x dx is equal to the limit as n goes to infinity, and this is read the sum, that sigma, that's the Greek letter sigma, and this is a lower bound, I equals 1 to n of f of x sub I star, delta x, is equal to, so when you take a limit of a sum, it becomes, that's where that s comes from, for sum from a to b, and that's called an integral of f of x dx. And let me tell you a little bit about this notation. we didn't have a lot of experience doing this yet, so this is a notation for writing sums very compactly, and that's read the sum from I equals 1 to n, from down here to up there, of f of x sub I star delta x. Now, I equal 1 to n means I is equal to 1, 2, 3, all the way to n. And I thought I would write this out for you. So if I put 1 in here, only I is being substituted. So that gives me f of x sub 1, and that's a star, delta x. Then I'm going to plug a 2 in to this right here. So this right here is what I'm substituting my I in for. So you'll see if I put a 1 in, I get the sub 1 star delta x. Now the sum says I add the next one with I equals 2 in it. So that's f of x sub 2 star delta x plus, and then put a 3 in there, f of x sub 3 star delta x. This could go on forever. Plus I put in a 4, x sub 4 star delta x. Just to show you you're adding up these products, plus dot dot dot, plus it does end. Where does it end? It ends at n. I equals 1 to n, so the very last one's going to be x sub n star delta x. And I can also factor out a delta x out of all those and get f of x sub 1 star plus f of x sub 2 star plus f of x sub 3 star all the way to f of x sub n star. So just to what this means. Now, if I look at the picture here, what we're talking about is adding up these rectangles. So your A, they're saying that this is your x sub 0, and this is x sub 1, and that's x sub 2, all the way to B is x sub n, because you've got n rectangles there, and each rectangle has a subinterval, like the first one is x sub 0, x sub 1, then x sub 1 to x sub 2. So this is the abstract or the general way notation instead of a specific example like we did before. This is a general example, and that's what your x sub 0, that's why it says up here a equals x sub 0. That means that's the 0th place, that's the beginning, and the end is x sub n. And then remember before we either picked a left-hand endpoint, a right-hand endpoint, or a midpoint. It turns out you can pick any point on the subinterval, and that's what they're calling x sub I star. That's what the x stars are. It's just picking something on each interval, either the left-hand, right endpoint, midpoint, or anything in between. And notice your delta x is that little subinterval width, the width of the rectangle. And if you take the width times the height, and remember the height of this one is f of x sub I star. It's going to be the height of that rectangle. So this is what's going on. We're adding up all this. So it's a condensed way to write a sum. Now, if we take the limit as n goes to infinity, that means more and more and more of these rectangles, it will equal this area under the curve. Okay? So we're supposed to associate this with the area under a curve. All right, let's take a look at number 1. I have a function f of x here, and I have a function over here g of x, and we're supposed to find the integral from 0 to 2 of f of x dx. So that is looking at the area under this curve from 0 to 2. So we're looking at this area right here. All right. So let's see what that's going to be. Written this down here. So from 0 to 2 is going to be, well, you can divide it into pieces. I see that this is a square, so that's a 1 unit, 1, so it looks like 1, 2, 3, and those 2 corners will give me 4. Or you can do the area of a trapezoid, or you can do an area of a rectangle and the area of a triangle here. So it depends on how you want to look at this. So if I were to divide it into this rectangle here, I'll do that. So that'll give me, that rectangle is 2 times 1, right? 2 times 1, and then the triangle is going to be 1/2 the base times the height, and the base of this triangle is 2 by 2, and that gives you what? 2 plus 2 is 4. All right, so we are just calculating areas, trying to associate this integral symbol, and remember you read from 0 to 2 of f of x dx. I'll be back to do number 2.